It sure would be nice to control the weather. You could guarantee you'd always have a sunny day for a picnic or call down some rain if your garden's looking a little dry, but we humans cannot do that because we are not penguins. Whether Antarctica gets nice sunny days or overcast skies might have a lot to do with its best-dressed residents. Here is how penguins, and I am not joking, might control the weather. Penguin colonies in Antarctica can get pretty darn big. Many have tens or even hundreds of thousands of breeding pairs, and with a lot of penguins comes a lot of penguin poop. All of that poop gives off a gas called ammonia. You might know it as an ingredient in plant fertilizer, or things you can use to clean your bathroom, or pee. In fact, seabird poop is such a rich source of ammonia that back in the 19th century, people were mining entire islands for buildups of bird poop to bolster their crops. Not exactly a glamorous job. But in places like Antarctica, where no one's going in and messing with penguin droppings, the ammonia gets into the atmosphere. There, it can link up with other chemicals in the air and help form the earliest seeds of clouds. Clouds are mostly made of droplets of liquid water. In order for clouds to form, the gaseous water vapor in the atmosphere needs something to condense onto in order to become those droplets. That something could be a bit of dust or some soot from a fire, but it could also come from natural chemical reactions that occur in the atmosphere. Sometimes when different gases get together, they can link up and form a tiny solid or liquid particle. At first, those little particles aren't big enough to start forming clouds on their own, but over time, they can grow into bigger particles. They don't even have to get all that big. Once the particles get to be a few dozen nanometers in diameter, they become cloud condensation nuclei. Those are particles big enough for water vapor to start condensing on them. Just for context, the particles only need to be about 1,000 times smaller than the width of a human hair. Why do we always use width of a human hair as the comparison? I feel like there's gotta be something else. In Antarctica, many of the particles that go on to become cloud condensation nuclei are thought to start as clusters containing sulfuric acid and ammonia. They can also contain chemicals called amines, which are related to ammonia, among others. The sulfuric acid mainly comes from microorganisms in the ocean. Phytoplankton emits something called dimethyl sulfide, which reacts to become sulfuric acid. And the ammonia comes, in large part, from penguin poop. Normally there would be other compounds in the atmosphere forming these tiny starter particles too. They might be things like decaying plant matter or industrial emissions, but there really isn't much of that in Antarctica. It is the world's largest desert after all, so ammonia from penguin guano or penguin poop ends up playing a big role in cloud formation. Now, we've known about this for a while. Studies have linked this particle formation to ammonia from penguin colonies since 1998, and more recent research has presented an idea for exactly how those particles form. But as it turns out, these poop-based specks could impact cloud cover over much of Antarctica and maybe help keep the entire continent cool. But before we talk about why, all science needs funding, so let's go to a quick break.
Thanks to Jump Statistical Discovery for supporting this SciShow video. If you've ever had trouble finding the interesting result in a huge dataset, you're not alone. It can be really hard to see the forest for the trees. That is why Jump exists. Jump helps scientists turn messy, complex data into something they can visually explore and understand. Jump makes the jumble of numbers meaningful by making patterns, relationships, and outliers visible in seconds. But it's still you working with the data. You can build these skills yourself with Jump's free on-demand workshop, download the free trial and a sample dataset, and start your journey into data visualization and exploratory analysis. You don't need to be an expert statistician to get started. It's designed for scientists, engineers, and curious learners alike. You can check out the free workshop at the link in the description.
In a 2025 study, a team of researchers set up equipment to monitor ammonia levels at an Antarctic research station near 2 penguin colonies. They found that airborne ammonia concentrations were higher when the wind blew in from the direction of the penguin colonies, and they only saw new particles forming when the wind came from that direction too. Along with ammonia, the team also spotted a chemical called dimethylamine. Even a little bit of dimethylamine can help speed up the formation of those ammonia sulfuric acid particles. And good thing for the scientists there wasn't a lot, because dimethylamine smells like rotting fish. Yummy! The scientists weren't able to confirm the source of the dimethylamine, but much like with the ammonia, they saw more dimethylamine when winds came from the direction of the penguins. That's not entirely surprising. Penguin guano can produce amines, so it makes sense that dimethylamine could have come from penguin poop just like ammonia. So lots of penguin poop means lots of these little particles that can contribute to cloud formation. That was true even after the penguins left the colony site on their annual migration. Ammonia levels stayed high for more than a month after the penguins took off, but not literally took off because they don't fly. A separate study from 2024 also suggests that ammonia levels in the air from penguin guano could spike when temperatures fluctuate above and below freezing over the course of the day. Ammonia itself doesn't last very long once it's in the atmosphere, but those particles it makes with sulfuric acid do. The particles could end up getting blown elsewhere on the continent, so penguin poop could affect cloud cover far from their homes. Extra cloud cover could help keep Antarctica cool in the face of climate disaster, but we need more research to figure out exactly how that will play out. Clouds reflect some of the light and heat from the sun back out into space, which could help keep temperatures low. On the other hand, clouds also lock in some of the heat that makes it through and prevent it from escaping the atmosphere. To make things even more complicated, climate disaster is already causing some penguin populations to shrink. Fewer penguins means less penguin poop, which could then mean fewer clouds. Even though we don't understand their effects yet, this is a strong argument for protecting penguin populations. They might protect a whole continent in turn. So it looks like to really understand and manage climate change in Antarctica, we'll need some help from these funny little guys in suits who like to tap dance and also surf.